So recall that chemistry is the study of matter. And when we studied matter, we said that we could describe matter using the particle theory of matter. And one of the main points there is that all matter is made up of these very tiny particles called atoms. And so today we're going to take a look at what atoms are and how they relate to elements. And then eventually we'll be able to relate elements to things like compounds and molecules. So atoms are the smallest unit of matter. Um, if you take a look at this little Lego house here, it's made up of a whole bunch of little Lego pieces. And one single piece, one single Lego piece would be like an atom. So if we had a desk, it's made up of a whole bunch of particles connected together. If you take the smallest piece out of that, the smallest piece that you could break it down into, that would be considered the atom. So the atom is the smallest unit of matter, or it's also the smallest unit of an element. And so we'll take a look at how that relates as well. So an element is a substance that's made up of only one type of atom, and you can't break it down to anything simpler. And so there's a lot of elements that exist, and you can find all of those elements on the periodic table of elements. So we saw the example of the Lego house. The little Lego pieces were like the individual atoms. So you had a red Lego, a blue Lego, a green Lego, a yellow Lego. Think of those as the elements. So the different types of atoms that exist, like the different colors of Lego pieces, those are the elements. So in nature, we can find, for example, hydrogen atoms. That's one type of atom. We can find helium atoms. That's another type of atom. Lithium, beryllium, boron, carbon, nitrogen, oxygen, so on and so forth. So these here are just the different varieties of atoms that exist. And we can take these and connect them in different ways to make things like compounds, to make molecules, and we can combine those to make even bigger compounds, and we can just keep connecting them in different ways. So atoms are the smallest particle of matter. They're the smallest particle of an element. It's if you were to take, let's say, a gold watch, for example, made up of AU. If you were to take a gold watch and cut it over and over and over and over and over again until you couldn't cut it anymore, at that point where you couldn't cut it anymore, you've now reached the gold atom, one single gold atom. So there's gold atoms, carbon atoms, lead atoms, oxygen atoms, helium atoms. All the elements are the different varieties of atoms that exist. There's 118 elements on the periodic table, but keep in mind that there's way more than 118 molecules and compounds that exist because these elements can be combined in different ways. Kind of like if I had 10 Lego pieces, I can make many, many, many types of structures and shapes because I can connect them in different ways. So understand that atoms are extremely small. We often give this example here. So if you take a look at a pencil, just to let you know, is not lead. We call it pencil lead, but it's not. It's actually graphite, which is a form of carbon. If I were to cut the pencil lead there or graphite over and over and over again until I couldn't cut it anymore, at that point, that's when I've reached the atom, the smallest piece of matter. But keep in mind that we wouldn't be able to see that because if we look over here, let's just take a look at how small an atom is. One single hair is 500,000 atoms wide. So that's how small a single atom is. You can fit 500,000 of them across a single hair strand. Extremely tiny. You can watch this video if you want to get a better understanding of how small atoms are. This does a great comparison of that. Now, understand that atoms are still made up of smaller parts. The smaller parts that an atom is made up of are called the subatomic particles. Sub meaning below or smaller than. So we have the subatomic particles, and those three subatomic particles that exist are the protons, the electrons, and the neutrons. So here we have a model of an atom, meaning a simplified representation of what we think an atom looks like. We have the center part here called the nucleus, and in the nucleus is where we'd have our protons and our neutrons. And then orbiting or surrounding the nucleus, we have shells which have our electrons. So our electrons are basically just kind of flying around the nucleus. Electrons are not in the nucleus, they're orbiting the nucleus in areas called shells. We sometimes call these areas energy levels. So shells or energy levels is where the electrons reside. Now, these three subatomic particles have different properties. So one of the main differences between them is their charges. So protons, abbreviated P here, has a positive charge, +1. Electrons, they have a negative charge. I put E here, but we often represent electrons as E minus, for example. Neutrons, neutral. No charge for neutrons. No charge for neutrons. They differ, of course, in their location. Like I said, the protons and neutrons are both in the nucleus, whereas the electrons are found in the shell, orbiting, moving around the nucleus, or we can call this, again, energy levels. And they also differ in their masses as well. This here, what I have in this table, is the relative mass, meaning how they compare to each other. So, for example, let's say an electron had a mass of 1. The protons and neutrons are 2,000 times heavier, 2,000 times more massive compared to the electron. Protons and neutrons are very similar in mass, but they're much larger than the electron. So it's almost like the electron's not even there on a mass level. Electrons are very important for chemical reactions because that's what's involved in chemical reactions. But at the mass level, it's really the protons and neutrons that give the atom its mass. I could have also written this down in terms of atomic mass units, right? I wouldn't put grams because these are very small. So atomic mass units, we sometimes call that AMU. If I did that, I'm just going to write these in there. If I did that, essentially this would be 1 atomic mass unit. The electron would be 0 atomic mass units. It's negligible. It's so light we don't even count it in the mass. And the proton would also be roughly 1 atomic mass unit. And so when we go and try to find the mass of a single atom of something, we just look at the number of neutrons and protons that it has, and we're going to go and take a look at how to do that later on. So what you've learned in this lesson is that matter is made up of very tiny particles. The smallest of those particles is the atom. There's different types of atoms that exist, and those atoms are found on the periodic table of elements. Elements are essentially just different varieties of atoms that exist, and we connect them in different ways to make molecules and compounds. Remember that atoms are, although they're very small, they're made up of smaller parts as well, called the subatomic particles: protons, neutrons, electrons, and you should know where they're found, their properties, their charges, and their masses as well.